All right, 1.2, graphs of absolute value functions. Objective students will be able to graph absolute value functions in the form of absolute value of x minus h and the absolute value plus k. All right, couple things to review. One, I want to make sure we all are very clear on what an absolute value does. Okay, so let's just play with this. If I took the absolute value of 2, a lot of times I see students say, oh, well, that's -2. No. What is absolute value? It is simply the distance that number is from 0. So if we think about this, here's 0, here's 1, here's 2. How far away is 2 from 0? Well, it's 2 units away, so the answer is 2. All right? In the same way, what if I did the absolute value of -2? Well, here's -1, here's -2. That is also 2 units from 0, right? So that also equals 2. This is important, okay? So absolute value is simply the distance that number is from 0. That's all it is. That's why you always get positive numbers out, because you always get a distance from 0, okay? Now, let's talk about absolute value functions. Here's what an absolute value function typically looks like. Most of the time, our a value will be 1, and then the h and the k will tell us the vertex. We'll talk a little bit about that in a second. What I wanted to point out is that when we get to chapter 3, we're going to be dealing with quadratic functions. And I just want you to see how similar these are structured, okay? See how there's an a, there's an a. There's an x minus h inside parentheses here, and then being squared, and inside here it's inside absolute value signs. And both of them have the k on the outside. They are very similar, and they're very similar what you do with them. What do I mean by the vertex? Well, the vertex is always this little corner. It's like the starting point of the graph. So we always want to find out what the vertex is. And the h and the k represent the vertex. So it'll be the same thing with quadratics. The a is what scales it, and we'll play with that more throughout this chapter, and especially in chapter 3. But the a scales it. We also could say the a is kind of like the slope on the right side. So you might want to say that the a is the slope on the right. Okay. So let's talk about a couple things here with this. See that minus sign right there? That literally means x minus h. So what's going to happen here, and we'll play with this a little bit more, but if this was like a -2, the h wouldn't be -2. It would just be the 2. See how the vertex is whatever h is? There's always a minus sign in front. So it's literally always the opposite of how it looks. And we'll play with that more in a little bit, but I want you to see that. The h is always the opposite of how it looks inside the function, and the k is exactly the same as how it looks. H is the opposite, k is the same. Let's see. The mother function or parent function of the absolute value is shown to the right. Okay, so here's your basic parent function. It's just y equals the absolute value of x. There is no h inside there, so you could say that the h is 0. There is nothing being added out here, so you could say the k is 0, and so our vertex is at this point 0, 0. Hey, look, that's what we got. The vertex is at 0, 0. There is no, really, there's no number out here in front. If you could think of it as being like a 1 out there, because, you know, when you multiply by a 1, you just don't even have to write it. But if you think about there being a 1 out there, then that would mean that our a value is 1. And look, remember our a value is the slope on the right side. Look on the right side. It has a slope of 1. Does it go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so on? Okay, slope of 1. On the left side, it's always the exact opposite slope. So if this is a slope of 1, then this must be a slope of -1. And sure enough, down 1 over 1, down 1 over 1, down 1 over 1. It is a slope of -1. Okay, so notice the h and k values are both 0, and the a value is 1. All absolute value graphs are simply a transformation. And what's a transformation? It's just like a shift, like you can move it left or right, up or down. A scale and or a reflection of this original graph. So every graph we do will look something like this. It might be, the V might be like a little bit narrower. It might look like that. It might be reflected. It might be a little bit wider. But they all will look like some type of V, either a right side up V or an upside down V, or a really wide V or a really skinny V, but some type of V. So let's do an example so we can kind of better understand this. Example 1. If f of x equals absolute value x, while g of x equals x minus 3 inside the absolute value and minus 5 out here. Since we can think of g as x as a translated, okay, translated means like a shifted version of f of x, complete the description of the transformation. So to get the function g of x, shift f of x, okay, so remember the k value, let's go back up here and look at it a little bit. Remember the k value is really just the y value of the vertex, right? And the k value is exactly the same. So we could say we could shift it down by 5 units. Okay, that's what that does. The k value is the y value of the vertex, so that's what moves it up and down. And then in the same way, we could think of this, but remember we always do the exact opposite of the h, okay? Down by 5 units and to the right by 3 units. Now, why did I say to the right? Because I know it looks like it's negative, but whenever we were looking at our h value, there's always going to be a minus sign in front of it. So we have to say, okay, what's the opposite of what it looks? It looks like negative 3, so we need to think of it as positive 3. And h deals with our horizontal movement, left to right movement. And so if the h value is 3, it's going to shift over 3. So that's why I said shift right by 3 units. Okay, that's all that this does. So this shifts it to the right 3 because the h value shifts it left and right. This shifts it up and down. The h value is opposite how it looks. So therefore the h value is positive 3 and the k value is negative 5. That may be worth just marking here. We might want to say the h value is positive 3 and the k value is negative 5. That's going to be important to be able to identify the h and the k as we move on. Okay, so let's do another example here. So example 2 says function g of x to the right can be thought of, oh, I think it's gotten kind of shifted. I think it got covered up. I think it was supposed to say thought of as a transformation of f of x. I think that got cut off when I put this picture in here. So function g of x, here's g down here, can be to the right, can be thought of as a transformation of f of x. Okay, so you have f of x, you have g of x. So what changed? Okay, a couple things changed. The first thing that changes, f is pointing up in a positive direction, and g is pointing down. And by the way, we could tell, if we look at this real quick, we can actually tell what f of x is. F of x is just our parent function, our basic parent function, same thing as what we had in example 1. So let's just go ahead and write that f of x just equals the absolute value of x. Okay. The first thing I noticed, we did not change the h or the k because we didn't change the vertex. See how they both have the exact same vertex right there? So we didn't change the h or the k. What we did change was which direction it goes. And the only thing that changes the direction is the a value up here because that changes our slope. If we look on the right, we can figure out what the slope is on the right, and we can figure out what the new a value is. So g of x is going to have some new a value, and then it's still going to be absolute value x. We're going to put an a value here, and that's gonna stay the same. Just all we're going to do is change the a value. We're not going to do what we did here and put an h in and a k in because, again, they have the same vertex. All right, so let's look and see if we can figure out what the slope is on the right side. Always on the right. It's always on the right. So let's do that. So if I go into here, what does it look like the slope is? It looks to me like it hits this corner here. And that's the only one that I can be for certain that it hits a nice neat corner because it looks close here but not exact, close here but not exact. So that's the only one. So what is this slope? Well, this slope appears to me to be going down 5 and over 2. So the slope on the right side is negative 5 over 2. That must be our a value because our a value is always the slope on the right side. So you can see how using learning slope from last chapter would be really helpful. Okay, so since that's our new a value, I just go over here and I put the a right in front, negative 5 over 2. And now I've come up with the equation for this function g of x. So f of x is the original, the mother function, absolute value x. All that changes the a value. The a value is just the slope on the right side. So if I figure out the slope on the right side, I change the a value. And what I mean by change the a value is I just want to point out, if there's no number written out in front being multiplied by this absolute value x, then the number is actually a 1. There's a 1 right there. We just don't write a 1. Just like you didn't write a 1, like if I wrote x, that's the same thing as saying 1x. We just don't write it like this, right? We write it like this. So we're going to do the same thing with absolute value functions. We would do the same thing with parentheses. We don't actually have to put a 1 there, but there is an implied 1 going on there. Okay, practice 2, very similar to example 2. I want you to just take a look at this. I want you to see you have your original function, f of x, which equals absolute value x. So they tell you that. And they want to know what's the new equation of g of x. So it's just like this one. You just need to find the new slope. So what is the new slope on the right side? We only care about the right side. And so you're going to write your new equation, g of x equals some new a value, absolute value of x. Since a is all that's changing, right? The vertex didn't change at all. If you look right here, they have the exact same vertex. So you don't have to worry about changing the h or the k. That didn't change. All that changed was the a value. Go ahead and give it a shot, and then pause the video when you're ready to check your work. All right, as I zoom in here, I can see that there's a couple points that I can definitely tell where they are on this line. It looks like it's going up 3 over 1, up 3 over 1. So that means that the slope on the right side of g is 3 over 1 or 3. If the slope is 3, then the a value is 3. So I'm just going to take that and plug it in for a, and I have my equation. G of x must equal 3 times the absolute value of x. Boom, boom, boom. I have the new equation. Okay, so hopefully you understand what we're doing there. We're just trying to find the new slope on the right side. Then we put that in as our a value, and we are done. Okay, let's go to the next page. All right, let's put it all together here now. We're going to actually graph an absolute value function. So I want to just rewrite the basic layout of an absolute value function. Remember, it looks something like this. And we can put an f of x here. And let's just recap. What does everything do here? Okay, this is going to be the slope on the right side. The h and k are the vertex, right? Where this is the x value of the vertex, and this is the y value of the vertex. Vertex, remember, is the corner, right? So if you had some graph that looks like a V, that's your vertex right there. So what I would like to do is figure out what is the h and what is the k first. That's the first thing I would do. Well, the h looks like it's 4, but remember, the h is always the opposite of how it looks. So this looks like positive 4, therefore our h value is negative 4. The k is exactly how it looks. The k looks like a 1, so it's just a 1. So that means our vertex is at the negative 4, comma 1. That's where our vertex is. So let's go to that point. Negative 4, 1. Boom, right there. Found the vertex. All right, now what's the a value? The a value is negative 2, right? Let's highlight all this so you can see what I'm talking about. So we found the h from that, found the k from that, and now we're going to find the a value. All right. Oh yeah, there's your h, there's your k. Okay, so now that I know the a value is negative 2, I can just start graphing this thing. I'm going to go from my vertex, I'm going to go down 2 over 1, down to it. So the vertex is a starting point. I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. But remember, we are going to do on the left side, we're going to do the exact opposite. So since I went down 2 over 1, this slope technically would go up 2 over 1, or you could think of it as down 2 back 1, okay? So down 2 back 1, down 2 back 1, down 2 back 1. It should be an exact, if there was a line right here, they should always mirror each other perfectly. So boom, boom, and now we have graphed the absolute value function. Not too bad. You just got to be able to recognize your parts. This is very important to be able to recognize, okay, there's your A, there's your H, there's your K. The H is always the opposite of how it looks. Plug it all on the graph, you're good to go. All right. On this one, I want you to try to see if you can write the equation yourself. So they gave you some pieces here in the puzzle. We know a few points. We know where the vertex is. And we know this point here is on the graph. So maybe we could figure out the slope on the left side. Or what I would do, and I'm just going to recommend this to you, remember, this line has to be a perfect mirror of this line. So if this is a point on the graph, then we also know that this is a point right here on the graph. And that point right there is at 0, 2. And this point right here is at -1, -2. So go ahead and give that a try. Pause the video and then come back when you're ready to check your work. Okay, so hopefully you found that the H is -1, the K is -2. And there's a slope here that's going up 4/1. The slope on the right side is 4/1 or 4. So your new A value is 4. So if you plugged everything in, you got an A value of 4, an H of -1, a K of -2. Remember, there's always a minus here. So when you do minus and -1, doesn't that simplify? So really, we would write this equation like this. Instead of x minus -1, we would say +1. Oh, and I meant to put that in green. But then out here with the K, it just stays as -2. And there's our equation. That's what you should have gotten. All right, see you guys in the next video.